For today, we're going to talk about the greatest common factor. Now, a factor is a number that you could multiply another number by to get the number in question. Like, for example, 6. All the different factors of 6, you can multiply 1 times 6, right? Or you can multiply 2 times 3, right? Or you can multiply 3 times 2, but we already have that, so we stop here. So these are the different factors of 6. You got 1, 6, 2, and 3. Now, factors of 9, or of course we can multiply 1 times 9, right? We can also multiply, we can't multiply 2 times anything, but we can multiply 3 times 3. We can't multiply 4 times anything, 5 times anything, 6, 7, 8, and 9. We're back at 9, so we stop when we get to a number we've already gotten to. So these are the different factors. Now, between those two lists, the greatest common factor is 3, right? That's our greatest common factor. So the GCF of 6 and 9 is 3. So say for instance we have another problem, right? We're going to look at 12 and 16. So this is one method, right? We can list the different factors of a number, right? So for 12, of course, 1 times 12 is even, so we can do 2 times 6. Alright, we can also do 3 times 4. Well, we already got 4, so we can stop here. Those are the different factors of 12, right? And so for 16, of course, 1 times 16, we could do 2 times 8. We can't do 3 times anything, but we can do 4 times 4, right?
And we can't do 5. We can't do 6 times anything. Can't do 7 times anything.
But we can do 8 times 2, which we already have here. So we stop there. These are the different factors. And if we scan the list, we have all these factors. Of course, we have 1 in common. We have 2 in common. And we also have 4 in common. So the greatest of all these numbers we got circled is 4. Okay, so the GCF of 12 and 16 is 4. Alright, and that's one method. Another method, let me take these same numbers, is using prime factorization. Prime factorization. So let's look at 6. So we know 6 can be 2 times 3. And here both of these are prime, so we can't go any further, right? And we look at 9. 9, of course, is 3 times 3. And so we circle all the common primes that we have. And here we go. We have 1, 3 here, 1, 3 here, so the GCF is 3. Right? It's 3 between those two numbers. And here we're going to do 12 and 16 again. 12 and 16, we know it's even, so we can do 2 times the number. 2 is prime, so we can't go any further there. Alright, 2 times 6, and we know prime factorization of 6 is 2 and 3. So now for 16, it's even, so we can do 2. 2 times 8, right? And 8 is even, so we can do 2 again. 4, right? And 4 is 2 times 2, right? So we can circle all the things we have in common. So
we have a 2 here, right? That's prime. We also have a 2 here. We have another 2 here. We also have another 2 here.
Now we can't circle these 2's because we don't have matching 2's over here. So the greatest common factor is as many primes that we have in common. And we have 2 sets of 2's for each of them. So there's 2 times 2. The GCF is 2 times 2. We multiply the things we have in common, which is 4. So here we go. We have that 4 again there. Alright. So our GCFs, those are 2 different ways of doing it. Right. Now I'm going to show you another way, another little trick. It's kind of an ancient technique. And so here we have 6 and 9 again. Right. Now, so these are three different methods or three different algorithms for solving the problem. In this one, we just subtract, we repeated subtraction. We keep the lowest two numbers each time and subtract them, right, until we get to 0, and then we stop. And then we take the last number we had before 0. So for example, we have 9 and 6. So 9 minus 6 is equal to 3. So we take our lowest two numbers, which are 6 and 3, and we subtract again. 6 minus 3 is equal to 3. Okay? And so we take our lowest two numbers, which are 3 and 3. So 3 minus 3 is equal to 0. So here's the 0 here. So we take our next number up. So our GCF is 3, right? Let's do the same thing with 12 and 16. 16 minus 12, right, which is equal to 4, right? Take our lowest two numbers, and we have
12 minus 4, which is equal to 8. Take our lowest two numbers again. So we got 8 minus 4 is equal to 4. Lowest two again, 4 minus 4 is equal to 0. So
here at the 0, so we take our next number up, and it's 4. So here we go. 4 is our answer. Alright, so there's three different methods for finding the greatest common factor. Now this method can become very, very long, you know, but this method right here is really good for computers. If we were going to design a computer program, this is one of the best methods that we could use, is Euclid's algorithm. So this is good for computers. So, alright, there's three different methods. And we'll also look at this Euclid's algorithm a little closer in the next video, and how we can write the code.
we will write the code.